Hey guys, welcome to Learn with Anirudh. Machine learning is one of these fascinating domains that has taken over the world of modern computing. Of course, in a good way. Now, when we think about machine learning, in fact, you're using machine learning right now. If you're watching this video on YouTube, you're using machine learning as it is, and even I have used a lot of applications that are built, around machine learning while bringing you and, of course, creating this video at the same time as well. Now, the most relatable machine learning application that you might have used is the advertisements that you guys get shown on a daily basis. Have you ever been in a situation where you search for something on Google, 10 seconds later, you see the same advertisements on Facebook, you see the same advertisements on Instagram, everywhere you go? I bet you've been in this situation. Machine learning is one of these domains that is very subtly integrated into all of our daily lives. From your daily weather updates all the way to recommending good content for you guys to watch on YouTube, it is literally everywhere. Now, with this, you must be curious to understand how a machine learns. So, let's find out. So, introduction to machine learning. Let's first check out what the experts have to say about it. Now, Dave Waters is a very nice guy. He says computers are able to see, hear, and learn. Welcome to the future. And when you think about it, this makes so much sense. We are living the entire future, what we thought was unachievable maybe 15 or just 20 years ago. But then, before we actually talk about the future of machine learning, I want to take you guys to understand the origin of machine learning, of how we did come about to where we are today. The best part about this is, let's take a quick throwback to the 1950s. The 1950s is what, 70 years ago, and the world was radically different. Half the world was recovering from the onset of World War II. The world wars were done. Of course, the other wars were there. Princess Elizabeth, now known as Queen Elizabeth, took the throne. And of course, the first ever color TV show episode was aired in the 1950s as well. So, this is what was going on in the 1950s. But then there was one interesting thing in the 40s and the 50s was all about this person called Alan Turing. Alan Turing is a fantastic mathematician. He was very good with logic, and he was the person who was single-handedly responsible for breaking the Enigma code, the secret coding mechanisms that the Germans used during the World War to transmit all of their messages. Well, let's just say that Alan Turing had a really big part in helping the Allied forces win the World War. And it's not just that, that was in the 40s, of course. Since we're talking about the 50s was the origin of the terms such as artificial intelligence, the terms such as machine learning, and all of that. Of course, the terms weren't coined then, but let's hear what Alan Turing has to say. Well, in 1950, he said that a computer would deserve to be called intelligent if it can deceive a human into believing that it was human. Now, when you read it the second time, it makes more sense. Because with this as a premise, he gave us something called as the Turing test. Now, what is this Turing test that we're talking about? It's a very simple test. I'm going to explain it to all of you all now. Let's just say that you are a human questioner sitting on one side of the, one side of the desk, something like that, with your laptop, with your computer, and you're ready to ask a couple of questions. You ask the exact same questions to both a computer and a human responder. And in this case, the computer is not in front of you, neither is the human responder. So you have no audio or visual contact with either the computer that's going to respond to you or the human that's going to respond to you. So this is how you figure out if your machine is intelligent or not. When you ask the same question to both the computer and the human respondent, both will try to convince you into thinking that they're human beings. If you fail to figure out, and if you cannot find out which is which, if you cannot tell that the answer A was given by a computer, that answer B was given by a human being, well, in that case, the machine has successfully deceived you into thinking that it is intelligent. So this is a very simple premise called the Turing test, which eventually led to people understanding and thinking in a way which aligns very closely to the modern world of machine learning that we think of. Now, that was the origin of machine learning. Of course, we're all here to understand how machine learning works. Just before we dive right into that, I want you guys to understand what machine learning basically is. Now, machine learning, when you're talking about it in terms of a domain, let's talk about it in terms of a machine, a single unit first. A learning machine is any device whose actions are influenced by past experiences, says this person called Nils John Nilsson. And when you think about it, yes, it makes so much sense, because if your computer is basically you giving certain commands to it and it following the same commands. But if you're talking about a machine that learns has the capability that you train it once and it uses the same experience, the past experiences, whatever you have trained 10 minutes ago, it can use that to either give you meaningful inputs, meaningful outputs, or at the end of the day, it can use the same experience to learn to be even better than it was in that 10-minute duration, right? So this is a quick understanding of what machine learning is. And when you think about it, in today's world, machine learning is used everywhere, let's be honest. In fact, all the social media products, some of you all might be having your phone right now, swiping quickly through Instagram or checking your Snapchat real quick. Understand that machine learning forms to be a very, very vital component of the modern day social media products that we have. Now, I'm going to give you a very nice example to show you where machine learning is, again, very subtly integrated into our life, as I mentioned at the start. Now, let's just say that after 35 or 40 failed attempts, you and your friends finally get to plan that Goa vacation that you guys have been thinking for maybe for the last 6 or 7 months. You finally have all your tickets booked, you're ready to go. So what do you do when you go on your vacation? Not just Goa, when you go anywhere outside, right? You click a ton of pictures, you click a lot of selfies, a lot of groupies, and once you click all of these pictures, of course, you want to show the world that you could successfully pull off a Goa vacation, right? So we go on to our social media, we upload it for the world to see. Now the best part here is that as soon as you put it on Facebook, have you realized that when you and your friends, let's just say you've uploaded a groupie or a selfie or something like that, Facebook automatically recognizes the face that is there. First of all, it detects that there is a face in the image. That itself requires machine learning. And after face detection, it is not just telling you that, hey, there is a face in the picture here. It is telling you that, hey, is this that person, right? It is actually looking through your friend list, matching who that person is. Now, Facebook might have never seen that image before, because this is literally when you guys went on your vacation, right? It could have not seen that exact same picture before. But then it is still intelligent enough to detect the faces, eventually recognize who it is in that picture, and also automatically tag those people for you. Now, if you've uploaded hundreds of pictures, I know we all don't do it anymore, but probably 5-10 years back, if you remember, if we ever went on a vacation, all the pictures had to go on Facebook, right? So it would have been very, very annoying when you think about it to individually sit and find faces, tag these people, and ensuring that they are also a part of the post that you just posted on Facebook. But then we don't have to do all of that anymore. And when we look at it, it seems such a simple thing, but at the end of the day, there's a lot of machine learning that's working to bring us this beautiful feature. So that is machine learning. We quickly took a look at one or two examples of where we've used machine learning. So how does the entire world of machine learning work then? I'm going to give you another nice example. Take a look at this. Let's just say that all of you all watching this video, some of you all might be college students, some of you all might be school students, and even if you're not, even if you're a working professional, you can relate to this. So what do we do when we want to finish a course either in our school or in our college? We first go about buying all the textbooks, buying all the notes, materials, Xeroxes, everything that we require to study. We organize all of our data. The second step is we actually use all the organized work, all the timetables, the textbooks, all your plans and everything, and you start learning the actual subject or maybe any concept that you might be looking forward to learn. Now, after you have learned, how does your college or your school know that you have learnt it? So what they do is very simple. They just say, hey, close all of your textbooks, close all of your notes. We're going to give you an examination. Now, the examination is like a validation. It's like a verification to check if you have actually learned something, rather than, if we were to give you your textbook right then and there while writing your examination, it would not be called an examination anymore. Think about it for a second. Because if you find all the things in your textbook, you can copy it right there and you can paste it over here. There's no knowledge transfer that's happening apart from the skill of copying and pasting. Now, how is this related to the world of machine learning? In machine learning, we have very similar concepts to the examples that I just told you guys. The first step is data collections. Just like how you would collect your textbooks, here we will be collecting a lot of data that we require. The data that we want to use to actually teach our machine learning algorithms to, make them self-sufficient, make them understand what is actually going on. Now, if you watched my introductory video, if you watched my Python video, you will understand that computers are not really as intelligent as you think they are. It's because of the fact that at the most native level, at the most fundamental level, all they understand is two things: zeros and ones. So we need to provide certain data to help the computer connect certain dots. And to do that, the first step is always to collect the data, to process the data, and to eventually let your machine learning algorithm see the data. As soon as we have all the data ready, the next step is you learning for your examination. In this analogy, we would be actually training the machine to help it understand. So what we do is we train the machine once and it will learn from its own experiences later on. So let's just say that I have to do 10 things. Now, if I train my machine once, in the hypothetical situation, it might learn and it can do the rest 9 tasks all on its own. But if it's not machine learning, if it's a manual task, what do I have to do? I train it once, it finishes task number 1. I train it again, it finishes task number 2. So in that situation, what you really should think about is that I'm training the machine once, but it is using whatever it has learned as its own experience and build upon that further. Isn't that a beautiful thing? Well, it really doesn't end with that, because the next step is us trying to use certain concepts to verify, to validate if the computer actually learned anything, if your machine learning algorithm worked or not. This is exactly like how your teachers would give you the examinations, all the tests and everything in college. Now, I'm going to give you another example to align your learning closely into the depths of machine learning. Now, let's just say that you're trying to teach your machine to recognize what a cat or a dog looks like. Now, this might sound very funny to you. You might be saying, hey, why do I even have to train my computer to find out what a cat or a dog looks like? Don't you think it already knows that? Well, you might have the fastest computer or the most intelligent computer in the entire world, but unless you explicitly train your machine to understand what a cat or a dog looks like, for it at the end of the day, it is seeing all numbers. Even an image, the image of the cat and dog that you're seeing right now, we look at it as a cat and a dog. The computer at its most fundamental level is basically looking at it as pixels, and pixels are nothing but numbers, and those numbers come together to form colors, and that is what shows us as images. Simple, right? So the first thing is, when you want to train your computer to understand what a cat or a dog looks like, you have to teach it the characteristic of what a cat looks like or what a dog looks like. Now, both cat and a dog has 4 legs, it has a tail, it has 2 big fluffy ears, and they probably walk in a very similar fashion. So we need to ensure that it understands exactly what a cat not just looks like, but then what a cat actually is. And then what a dog looks like, maybe its behavior, its movement and all of that. But with just that, we cannot just say, hey, now my computer is intelligent and now it has learned. Not so fast, because we need to evaluate the computer. We need to evaluate the computer to see if it can figure it out if we provide a picture of a new cat, a cat picture that it has never ever seen before. Now, it's actually a very simple concept. Let me explain it to you guys. If I show the exact 10 images of cats, let's say, for my computer to learn, afterwards, if I use the exact 10 images to verify if it has learned something or not, it will not make any sense, because your machine already knows what the cat looks like from those 10 images. True verification comes when you show it another picture of a cat, when you show it that 11th picture of a cat that it has never seen before. And if it can then predict that, hey, this is a cat, well, your machine has successfully learned from its experiences, correct? But then there are many cases where it's not as easy and straightforward as this. Since it's a cat and a dog that we're talking about, it can get confusing to the machine as well. As I just told you, there are very similar characteristics to a cat and a dog. So when your machine learns incorrectly, what you do basically is you retrain the machine. You give it maybe better quantity of data or better quality of data, such that it can completely grasp the fundamentals of what a cat looks like, of what a dog looks like. And once it has retrained on this, later you can ask it again whether if it can figure it out or not. And I bet with more data, it's not always the case, but with more higher quality of data and with higher quantity of data, in majority of the cases, it does learn better, it does understand better, and your accuracy can definitely go up. Now, there is a lot more involved than just the quantity and the quality of data, but just to simplify and give you the entire picture, I thought this would be a good example to tell you guys. Now, since machine learning, we're talking about machine learning, and all of you guys are very excited to get started with programming. All of you are already asking me to start showing Python code and how we can dive right into the heart of programming. I appreciate all of your enthusiasm and understand that there is definitely a ton of content which involves a good amount of theory and a lot of programming that's coming your way as well. So make sure you guys are subscribed to the channel. So whenever I put out these videos, you guys will be the first ones to get notified of that. Well, coming to machine learning and programming, the first thing that I want to tell all of you all is that Python is the most used programming that we have in the entire world for machine learning. Now, I'm not stating that Python is the only language that you can use for machine learning. There are many other languages through which you can achieve a good amount of machine learning as well. But Python and machine learning are almost like, I want to say, a match made in heaven. Python's very easy to use syntax, and machine learning's complexity nullify each other out. So the easiness that Python brings into the picture and the difficulty that machine learning brings matches really well, and at the end of the day, it's a very easy product, a very easy domain for all of you all to learn. And in all honesty, as I've been mentioning, machine learning is actually super easy, and I'm 100% confident that all of you all watching this video can become experts in machine learning. Then you'll have a question at this moment of time saying, okay, we know we can probably become experts in machine learning. So is our traditional way of programming and machine learning programming exactly the same? Well, let me tell you that it actually is not, because in traditional programming, right, your Java programming, C++ programming, what happens usually? What we do is we provide certain data input. We create variables int a, float b, char c. We have a string input or something. We write a program to connect the data and the program, and once we have our input and once we associate it with the program, it runs through a compiler, runs through an interpreter, and gives us an output. Correct? We have done this in our past. It's straightforward. It's traditional programming. So how is machine learning different then? Machine learning is different in this particular case. Take a look at it. There are subtle changes on your screen right now. Instead of giving the program as an input to our machine learning model, what we do is we give the output as an input. I know you guys are confused at this moment right now. I'll take you back to that cat and dog example we just spoke about. In the cat and dog example, if you notice, what I would have told the machine is that here are some of the cat and dog pictures that I want you to see and learn and figure out what a cat and a dog looks like. There I've already given it the output. I want it to figure out what a cat and a dog looks like, and it already has the output at hand. So all it has to do is it has to connect the dots between the input and find a way about how it can get to the output. So it already knows the answer, it just needs to find out how it can get to that. And eventually once it does that, once it starts learning, then it is rightfully called as a machine learning model after learning. Correct? So with this, I want to talk to you guys about one or two key pointers for machine learning really quick. So the first thing that I want all of you all to understand is that there are various types of machine learning. Just like how there's various branches in the world of data science, you have multiple branches in the world of machine learning itself, under which there are multiple ways of learning that a machine learning algorithm can use. There's supervised learning, there's unsupervised learning, and there's reinforcement learning. Now, I know for some of you all who might have never heard of these terms, or you might have never worked on these, it might seem that they're very complex. But then with the further videos that I have planned for you guys in the pipeline, I will make sure to find the easiest way. And I already have a ton of ideas to teach you about how easy it is for you to understand supervised learning and how easy it is for your machine to figure out how supervised learning works, unsupervised learning, and of course, reinforcement learning as well. Now, the other important thing that, I've seen the mistakes that amateurs do, of course, I'm not blaming you guys for it, is for the fact that you wrongly state something as a machine learning algorithm. Let me tell you this, an algorithm is the basic foundational code, the heart of the logic that is used for a machine learning model to learn. Now, you call the entity as a machine learning model only after it has finished its training. Before training, it's called as a machine learning algorithm, and after training, it's called as a machine learning model. So now you know the correct way to go about using these terms in conversation or maybe during your own learning as well. The best part about machine learning is that it is having a ton of impact in all of our lives, let's just be honest. And as per Google AI's blog, they say that their in-house deep learning and machine learning program is somewhere around 90% accurate in detecting breast cancers, while pathologists are at about 74% in terms of detection accuracy. Now, I'm not saying that machine learning algorithms are better than the doctors we have around, and it's not a competition, to be very honest. The best part here is that pathologists can use the machine learning algorithms to have even better accuracy down the line. They can bring their own expertise and further use the accuracy of a machine learning model to eventually help the world around us. And I thought this is a worthy mention because my journey into the world of machine learning began when Google started doing all of these experiments and they went public with their research. This is how I came into machine learning, because I absolutely loved the fact that we can use machine learning and bring it together with the world of healthcare. Computer science and healthcare are two radically different domains, and once you bring them together, you create such beautiful products. And we have thousands of products in the world of healthcare that use machine learning on a daily basis as well. And which is the other product that we use on a daily basis? Of course, it has to be Netflix, right? I find myself watching a couple of TV shows, watching a good amount of documentaries, learning something new, having a bit of fun, relaxing on Netflix. But did you know that as per Forbes, Netflix actually saved somewhere around $1 billion to all of its subscribers by recommending them personalized content. Netflix has one of the most well-tuned, one of the most sophisticated artificial intelligence entities, machine learning models, algorithms, deep learning stuff there. I'm going to be creating a separate video where I'm going to be explaining how Netflix makes use of the entire world of machine learning to bring such good content and to customize the offerings that it has for millions and millions of viewers it has around the world. But know that it has not saved $1,000 or it has not saved $2,000 or something like that. It has saved $1 billion by helping customers connect better with their product and thereby bringing in more subscribers at the same time. Isn't that absolutely fantastic? Well, if this fascinates you, I can tell you that as per me, as per Anirudh, you can learn a lot more about machine learning if you'd be kind enough to show your support to the channel by taking a second to hit that subscribe button. There's a lot more about machine learning that I want to teach all of you all about. This was a quick introductory video to help you connect with the domain. And down the line, we're going to be seeing a lot more content to help you guys understand all the nitty gritty confusing details of the world of machine learning, which makes the entire world think that machine learning is complex. Well, I promise you that it isn't. So thank you so much for watching this episode of Learn with Anirudh. I'll see you on the next one.